Start streaming, and we should be live. Can you check with Ollie if it's live? Can you check with Ollie if it's live?
There we go.
Okay. I'll ask you to.
Oh, why don't I just check on my phone? That means you're just streaming as well.
Okay, wonderful.
Well, hey, you're from the anime shop, so I need.
I am.
Yeah.
But here I am, Hacksoc James, not Anime President
Okay.
James.
Yeah, you thank you.
Does it make me cooler or less cool?
No comment.
So Daddy's got lost. So
Whereabouts is he?
I just asked him.
Wonderful. Is
Am
it
I
a
on
test
that?
card?
Can you see me?
And now, give it about 5 seconds. Has it swapped over to me?
Has it swapped over yet? Is it swapped over yet? I'll do it. Let's look at the pizza sign.
If you keep hold of it and then go out.
Yes, I'm not. I'll get the pizza roll, I think. Yes, there it is.
Okay, wonderful. Let's. Do we give it?
Ollie just said there he is.
Okay. Should we get started now, or should we give people a couple of minutes?
A couple of minutes.
Right. Okay.
Ollie says it's quite quiet.
Right. I will have to turn my microphone volume up a little bit. How about now? Is that better? I've just turned it up and just making sure that it's still working.
Better yet.
Okay, wonderful. That's. I'll just. Okay.
Off-site IT support.
Yeah. It's.
Wait, can he hear? Ollie, can you hear me at the moment?
Right. Everything's fine. Don't worry about it.
Yeah, Ollie can hear us. You can hear us? Yeah. Can you hear me, Ollie?
Okay.
Oh yeah, so there's no stream sound.
I'm going to say when it gets to 34 we start.
Should we count the people? It's definitely less than last time, but it's still. Yeah, they've nicely spread out here, so it looks like. It's really
I make it 39. Should we say we get started?
Can you turn up the mic a little bit more? Yeah, turn up the mic a little bit more.
Okay, that's right. Okay. Hello.
Hello, there we go.
I don't know.
Oh, crikey. It's a nice little LTT CPU shirt.
Thanks. I'm trying to keep up.
Right, okay.
Not the best time to get lost, is it?
So, Davy, stream chat. Stream chat's there. That's OBS. That's the audio control for the microphone. And we start when the banner goes up. Cool. Leave the banner outside in the next room. You don't have the plastic bit to hold it up.
Where is it? That's not good. I'm super glue in my bag.
No, right, leave it.
Got it?
No, haven't got it, leave it. We need to get started. Hello and welcome to the WAN show. Right. Hello, welcome to the second of our Hacksoc introduction events, where we're going to have similar style to last time. I've noticed a lot of you did go to Thursday's event, so it's very similar style, different talks. Next slide, please. No, that's on that laptop. Okay, we have a Discord. We have Twitter and Instagram. If you do those things, we have a website as well that will have our events on it. A nice calendar. It's great. Okay, next slide, please. We have a Discord. If I didn't already mention. Next slide, please. Hacknots is going to be a thing in about December. If you want to get involved, we will. More details to follow, but it will be a thing. Is happening. Just these bits. We also have a code of conduct for our events to make sure everyone's okay with everything. If you go there, you can find it. If something bad happens here, just speak to one of us committee. Committee, could you sort of raise your hand? Okay, the people generally located over here. Next slide, please. Don't turn on your screen recorders for this, guys. And that mainly applies to the people watching on YouTube currently, because this event is being streamed live to YouTube. Hello, YouTube. Okay, next slide, please. We have a second welcome event today, right now, and well done, everyone. You succeeded the first test of finding it. On Thursday, we have a programming cafe over at Jubilee in A32, and then then next Tuesday, that's a week from today, we have a Discord bots workshop. We've not 100% sure on the location yet. We will let you know in the Discord and the website as soon as we do know, and we're back to the start. So I would like to first welcome to the stage Sam King to talk about getting involved in the Nottingham tech community. Wonderful. Let me just go back to the combined, and I've got to just change the.
This is all going on in traditional Hacksoc fashion.
Yeah, it's live patching.
Yes.
Okay, wonderful.
Yeah, she's here.
Yeah.
Hello everyone. Allow me to be the first to say on behalf of all of us, like committee, former committee, and everyone here, welcome to the Nottingham tech community. So, who am I, and who am I to be welcoming you to the Nottingham community? Someone who hasn't lived in Nottingham for about 21 months now, so we persevere. Firstly, shameless plug, I am at King of Sams on Twitter, but I'm also an ex-committee member. I used to be a Hacksoc Speaker Acquisition Secretary, so it was my responsibility, a very, very burdensome responsibility, to go out into the local tech community, eat loads of people's pizza, drink all their beer, and attend all their brilliant talks. And basically, what I am going to do is I'm going to introduce you to a load of different events that take place throughout Nottingham that you can attend, and hopefully Hacksoc will be running a few trips to some of these talks in future, so you can find out what's going on in our brilliant community. So the first event I wanted to introduce is Tech Nottingham. Tech Nottingham takes place on the second Monday of the month. The team who organised that will drill into you the phrase second Monday of the month. You'll hear it every single time. And they also run Women in Tech Nottingham, which is the first Thursday of the month. And we have many fond memories of both Tech Nottingham and Women in Tech. They're brilliant events. Anna and Andrew, who are co-organisers of the event, are on our Discord, so you can go chat to them if you have any questions about Tech Nottingham. They're always happy to help. Honestly, they've been lifelong friends of Hacksoc. You can get involved with Tech Nottingham right now. On screen now, you can see a link to the Tech Nottingham Slack. And one of the points I'm going to stress later on in this talk is there are like the Tech Nottingham Slack is a great place to get started and get involved in the like wider Nottingham tech community, because you'll find that the people who turn up to Tech Nottingham and Women in Tech Knots, they appear in every other event. They organise all the other events, and they're always eternally evolved as the YouTube stream died now. Oh.
The slides are like the camera's just...
Okay, that's fine. The next Women in Tech event is on Thursday, 7th of October, and the committee are very keen for Hacksoc to really get involved with the Women in Tech event. And I should stress, it's not just an event for women. It is an event that is like...
Yeah, I just...
so it's an event that's for anyone who is an advocate of advancing women in tech events and just being allies of allies of women at tech events. I think it's a really great event. So get on that. I think Peter, you're organising an actual trip to.
Sort of. We're not hosting an event that time.
Yeah. Yeah. Okay. So there's no Hacksoc event on that day, even though it is a Thursday, which is standard Hacksoc event time. But instead, we'll be going over to Women in Tech together. Now an event I've never been to. It's on my bucket list, but I value my sleep. Not Techfest. Tech done quick at breakfast. So it takes place at 8 a.m. You can hear a few groans. Like, every Thursday. I definitely like to do it at least once, but this Thursday is probably not the one. Not going to lie, but we'll give it a go. Knots.js and Lust.js. They always they're going through a bit of a dormancy at the moment. They haven't hosted an event for a fair old while, but everything JavaScript, web technology, this kind of thing. Not just JS, but mostly JS. Yeah, they've partnered up with Leicester.js to form Midlands.js. So lots of events will be taking place in collaboration with the various different JavaScript enthusiasts throughout the Midlands, so that's always nice. You can meet people from a little bit further afield. .NET Knots. I've clustered together a couple of different events into these next couple of slides. This is an event about all things Microsoft, so everything from Microsoft mobile technologies to Microsoft web technologies, Azure, Xamarin, that kind of thing. So very good event hosted by Pete Gallagher, again a great friend of Hacksoc. We've had him in on a couple of occasions to talk about various different things. We had him introducing IoT. We'll see again, he runs an IoT event. The man is truly prolific. Like if there's anything tech in Nottingham, he's all over it. So the next Notch.js is that one's passed. That was relevant for the first event, but it is no longer. Nottingham IoT again, going through a bit of a dormancy at the moment, but no doubt it will be running again soon. The last one took place in December, and it was essentially an art special, looking at how we can combine art and technology. So that was brilliant. I did attend that one. It was really entertaining. Again, run by Pete Gallagher. So the most software engineering focused event that I mention here, DevOps Knots, talking a lot about software engineering practices, but also it can introduce you to a fair number of different technologies. Again, very tied into the Microsoft frameworks, because it's largely hosted by people who are either Microsoft MVPs or .NET advocates. Very good event. It's hosted at BJSS's office in town, so just right on the edge of Old Market Square. Very good event. And a bit of a special one for me. This is kind of my favourite tech event, and it's one that I kind of went to on a whim because I didn't think it was 100% relevant to me, but then I went and I had a fantastic time. Accessibility Nottingham. All about making tech inclusive. They cover everything from accessible web design to making appropriate colour choices to be accessible, because we learned that colour contrast can cause accessibility issues in tech. So they are friends of Hacksoc. They are we invited them in to do an accessibility special, and they in turn put us in touch with people from BBC Cape, who are an organisation advocating accessible technology, and we in turn invited people from BBC Cape to come and do a talk on neurodiversity, so that was really good. And I include this photo here of this guy. Does anybody recognise him? Not getting many people, but you might recognise him from Peaky Blinders. He was in the first couple of series of Peaky Blinders. His name is Sam Coulson, and I vaguely recognised him when I attended the event because he has subsequently retired from acting and has now pursued a career in selling and researching accessible technology. So if you want to go to events to meet Peaky Blinders, the Nottingham tech community is the one for you. So I've introduced a lot of tech events. You guys might be a bit overwhelmed. Am I going to have to remember all these things? No, you're not. I didn't. I put them in my calendar once and then saw if I could attend them. But I would say that the best place to start is get involved with these two communities, the Hacksoc Discord, big URL there, and also the Tech Nottingham Slack, as I said, because it's a great place to kind of get started. Also, I've realised that's the membership one, isn't it? You corrected me that last time. The Hacksoc Discord is there on the whiteboard. Yep, that's it from me. Thank you very much.
Who have we got next? We've got... Pardon? 3, 4, scroll. Jacob.
Is it me next?
Yes.
I thought I was second.
No, tough. You're next on the list.
Alright.
Actually, how's this going to work with you things?
Yeah, in terms of showing the oscilloscope, we could when I need to show that, we could move
Yep.
that camera down.
Yep. Well, yeah. Needs to be plugged in.
Actually, no, that won't work because no one here will be able to see it. Oh well, let's see what happens if they can see it on the slides as well.
Yeah. Okay, wonderful.
Fine.
So if I just go to there and
Am I in frame here? Can you see me?
No, you sort of have to be stood about there.
Okay, but I need to change the slide. Okay. Huh?
I can't.
Technical difficulties. This is why you don't run a hybrid event.
Test card. No.
Okay, nice.
Are you ready to start? I
Guess
can
so.
do the next slide.
Yeah, okay. Oh,
There you go.
starting now?
Yeah.
Alright, hi, so I'm Jacob, and I'm a third year computer science student here, and I'm also the treasurer for Hacksoc. So what I'm going to be talking about today mainly is... Sorry? Really?
Yes.
Okay. What I'm going to be talking about today mainly is what me and my group did for the second year group project, which any of you who are computer science students will have already done, where the project we did was we had to try and recreate the classic game Asteroids, but as accurately as possible to how it originally was. Next slide, please. Right, so I'm sure you pretty much all know the game. It's the one where you fly around in a spaceship and try and clear all of the asteroids off the screen. This is what it looked like. There's the arcade cabinet on the slide. So the reason we thought this would be so great to make is not only because it's fun to make, it's quite fun to make games, and recreating them. Why have you just turned the lights off?
Okay. Is that better? Can you see the screen now? Wonderful.
Oh, right, okay.
Had to turn it off and turn it on again.
All right, there we go. All right. So yeah, the reason we thought it would be quite fun to make asteroids, and the reason that I thought this would be a really fun project to do, was that asteroids, unlike a lot of other games, it actually uses vector graphics rather than raster graphics, and I'll explain what those are soon. So next slide. So first of all, we since this was all done online, the group project, and we didn't all have access to the oscilloscope, which I've brought along today, and I'll show you that later. to actually do something as a group, we needed to make a game that we could all work on. So we made a version of the game which can run on any computer, and we did this in C using the SDL library, which provides basically all you need to make a game. We even wrote things like the line drawing algorithm from scratch, just because we wanted to do it from as low a level as possible. But that still wasn't that accurate to the original one, because despite the fact that it was all drawn with lines, it was still being rendered on a modern screen, and that's not a vector screen at all. It's a completely different experience. So now I'll explain what the actual difference between raster and vector graphics are. Next slide. So raster graphics comes from raster scanning, which was used on old TVs and is still used on some TVs. And it's a pretty good way of doing it, because if you have a TV signal, you can't just send all of the pixels at the same time. In fact, there aren't even pixels. The way it works is that you essentially scan across the screen and take each row at a time. So you split the image up into the rows, and then for each row you just alternate the signal so that you can basically change how bright that particular part of the screen is. And what's interesting about this is that this means that you have a discrete amount of rows, because at one point it will, of course, go back to the beginning, and that starts a new row. But within the row, it's actually continuous, so there aren't pixels in this format. Well, you have unlimited X resolution, but limited Y resolution. So next slide. And so that brings me on to actual raster graphics, which is used by pretty much every monitor today. And what that means now is it just means it's made up of pixels. So any screen you can think of which isn't an oscilloscope or whatever, which use raster graphics. Even modern day CRTs, despite the fact that they actually do create the image, they do create actual light on the screen in the same technical way as an oscilloscope, like the one I have. So next screen. So vector graphics is the alternative, and that's used by, again, it's used by the oscilloscope I have today. The image on the left here is showing how you could draw a triangle in vector graphics. You can see it's a single beam on the screen, and it's just outlining the shape of the triangle to draw it, rather than doing it in rows. And it can be more efficient for some things. For example, if you just wanted a screen that had a triangle on it, this does seem like it would be the best way to do it. But obviously, if you wanted a lot of detail and just a picture which can't easily be broken up into the lines that create it, you would want to use raster graphics, and that's why most screens nowadays use raster graphics. It's just more convenient for general use. I've put the SVG logo on the right because that's scalable vector graphics, and yes, that is vector graphics, but of course when an SVG image is rendered on a modern computer, it's no longer really a vector, because it's being rendered on a raster graphics screen, and that's called rasterization. Next slide. So cathode ray tubes, normally just known as CRTs, are the way that my oscilloscope displays images, as well as those old big screens, the really chunky ones, and TVs and stuff. I'm sure you've all seen them, and you probably know what they are, but you might not know how they work exactly. You can see on the... Well, I'm not sure which image of this really shows it the best, to be honest, but I guess they both show different parts of it. The one on the right is a pretty good diagram, but it's only in 2 dimensions, so that would be like a one-dimensional CRT, I suppose, because the screen on that is only a single line. But the way it works is the cathode on the left-hand side is heated up to a pretty high temperature, and also a really high voltage is being applied between the cathode and the anodes that are further in the tube. And when those electrons are released by the cathode, they accelerate pretty quickly towards the anodes, towards the screen at the end. And by the way, the screen is covered on the inside with a fluorescent coating, so when an electron hits it, it just creates a little bit of light. That's how that works. What's next? Oh, the focusing coils. So, as I said, the cathode actually creates like a cloud of electrons. So you need the focusing coil to focus that cloud of electrons into a thin beam, so that the actual the actual dot on the screen isn't a big smudge. And then lastly, the deflecting coils. The purpose of those is just to change where the dot ends up on the screen, and that can be connected to like a VGA controller or whatever. That's just that just controls sort of what's being drawn exactly. But in terms of an oscilloscope, so I'll point out that the deflecting coils actually are electromagnets in most cases. So they are electromagnets in CRT TVs and monitors, but in oscilloscopes they're actually just charged metal plates. And the reason for this is the way that an oscilloscope works is it just takes in a voltage and uses that to determine the deflecting coil's value. So it's really easy to just plug that directly into the charged plates, and then there's no more circuitry involved. The disadvantage of that, though, is that those charged plates can't deflect the electrons anywhere near as much as using electromagnets, which is why for most consumer electronics they used electromagnets so that they could be a bit shorter, even though they were still a lot thicker than modern screens. Next slide. Right, so here's the inside of the little device that we made, and this plugs into an oscilloscope and uses the oscilloscope as the screen to play asteroids on. You can just about see, well, it's 3D printed because luckily I had a friend who had a 3D printer. I'm not sure what I would have done if not. And then you can see some buttons on top, which are the input. It's just like a little games controller. And inside there's a microcontroller, which is basically just a little computer. It does everything that a computer does, just really small. And that's got a Teensy 3.5. They're quite good, and particularly they're great in this case because they have two digital to analog converters, which it's basically an electronic component which you can give it from code or whatever a digital number, so a binary number, and then it converts that into an analog voltage between 0 and 5 volts or whatever the circuit's running on. And having two of those is exactly what I wanted for this project because the input to the oscilloscope is two analog voltages, and those control basically where a dot comes up on the screen. And if you move the dot around fast enough, it makes shapes, as I'll show you quite soon. But this circuit here looks really messy, and I would be surprised if anyone could make anything from this image. So next slide. Here's a simplified circuit diagram of it, although it's not even simplified really. This is just the circuit diagram. It was such a simple thing to make because, in terms of hardware, because the Teensy microcontroller had the digital analog converters, and other than that, it's all done in software. So we have some buttons at the top, and then those potentiometers near the middle, which are basically a resistor that has a dial on the side. That's just for changing the scale of the output image. And then there's the oscilloscope at the bottom that it just plugs into. So, next slide. Right, so first of all, I tried to draw squares, just as a proof of concept so that I can draw something. So what you're seeing there is the front panel of the oscilloscope. There's a few various dials, they're not too important. But the dial at the top left is that controls the time it takes for the dot to sweep the screen, because what oscilloscopes normally used for is looking at waveforms. So it just sweeps the voltage across the screen so that you can see how it changes over time. But then if I turn it all the way to the left, it goes into XY mode, which is what I have it on the right image here. And that allows me to draw the square, because that means that the absolute position of the dot on the screen is completely controlled by the X and the Y voltage inputs, which I'm plugging in from the little device that I made. So you can see to draw a square, it's pretty straightforward. On the left-hand side, the two waveforms that you can see, the one at the bottom is the X, and the one at the top is the Y. So if you can imagine, if you take any point at that, you can see that it corresponds exactly to one of the corners of the square. So essentially, I'm just making the beam travel between each corner of the square. And when the beam travels fast enough between two positions, it draws a line. And that's how come we have a square here. There's a problem. If we go to the next slide. Here was my first attempt at drawing a triangle, and it really doesn't look anything like a triangle, because in the code that I wrote, it was not the best way to do it. What I was doing was I just had a while loop, and each time I was setting the x to where the x needs to be, and then setting the y to where the y needs to be, and then just repeating, which worked for the square because the two different coordinates didn't need to be set at the exact same time, because only one moves, like only the x or the y changes at a time in a square. So the square was kind of a fluke. Any shape with diagonal lines just wouldn't work. So what I tried, there's this electronic component called a sample and hold, or something like that. And what that does is it takes an analog voltage, and then you basically tell it, okay, hold this voltage at exactly this level until I say that you can then change it. So the reason that would be useful is I can just get this component to hold both of the voltages to the exact same level, and then once I've changed the output of the microcontroller, I can then tell the sample and hold to update its outputs based on the new inputs it has. Unfortunately, this didn't work, despite the fact that I went to the trouble of buying and then setting up the sample and hold in the circuit. I'm not really sure why it didn't work, to be honest. So I came up with a little bit of a hacky solution, which will be shown on the next screen. So here we go. That now does look like a triangle. And the way I did this was actually quite similar to how we did the line drawing in the C version of the game on a modern screen. So what we do is, instead of drawing the whole, an entire line at once, we just break it up into a lot of small lines, and that just works because any small little staircasing effects will just not be visible to the human eye. And when I did that at first, okay, so a small technical detail is that there are 4,096 different possible values for the digital to analog controller. And if I had it at that resolution when actually drawing the lines, it just lagged. And if this thing lags, it just doesn't work, because you need to draw the lines really quickly so that persistence of vision and also the little dot takes a little while to fade. You need that to actually see it as lines rather than just a moving dot, which wouldn't be quite so impressive. So I implemented a thing in the line drawing code to just basically change the resolution while actually keeping it at the same technically. So this is the last slide. I was now going to actually show the oscilloscope working and playing. How much time? Why are you telling me the time? Okay, all right. So, okay, I will just...
Might leave the oscilloscope demo for pizza time, then we don't need to...
That's fine. Okay, right, we're going to save the oscilloscope demo to until we have pizza. That's the end of my time slot. So, yeah, thanks everyone. Any questions? Yeah?
If you staircase it, does it not become a massive display?
No, because it's not actually independent pixels. So for one thing, it's not doing scan lines. It's still drawing only where it needs to. It's starting in one place and then going exactly to where it needs to draw the line, rather than sweeping across every single line and setting a pixel where it needs to. All right, thank you.
Alex, you're up. Is that how you spell your name?
That's right, yeah. Wonderful. Do I need to talk into the camera then?
Yeah, just sort of talk that way. The microphone is doing the stream, and that is doing that, so it should be... You know.
Can you do the...
Yeah, wonderful.
Cheers.
We'll do.
Okay, got it. Cool. So, hello everyone. My name's Alex, and I'm the Cybersecurity Secretary for Hacksoc. Next slide. So yeah, my name is Alex. I'm Cybersecurity Secretary. I like cybersecurity, hacking and solving puzzles. Anything interesting, anything fun like that, sort of up my street. Next slide. So, why do I like it? And why do I think you should like it? Basically, you learn a lot. If you want to get a really good understanding of everything there is to know about a computer, you can't really go wrong, to be honest. You learn about everything because hacking encompasses everything. You learn a lot of skills, you learn how to manipulate those things that you learn, and you can put it on your CV and it looks dead good. You can take part in capture the flags. This is something I like to do. These are just little gamified versions letting you put to the test what you know, and it's it's good fun, and you can even sort of go extracurricular with that and go to events, make teams and have a bit of fun with that, so that's good. And you can type stuff into Linux and look cool, which is at the end of the day why most people do it, probably why I got into it, to be fair. Next slide. So yeah, why is it important? That's the number one thing, isn't it? Basically, the world's digital, whether we like it or not. Nothing short of a collapse of society is going to change that. A lot of damage can be done if you don't take caution, essentially. So you can be impersonated, you can be have your computer hijacked for nefarious reasons, or you could have your machine accessed by people you don't want accessing it, and that can end badly for you. So yeah, the ways that these evil forces sort of get into all that sort of thing is with weak passwords, vulnerable software versions, and etc. Really. So can I get the next slide? Cool. So I'm going to be doing a demonstration of how a weak password can let you down in terms of cybersecurity, and I'll be showing an instance where a web application can be broken into because it had a weak password. But before we get into that, I'm going to briefly explain how we're going to do it. So let me just hop on to the next slide. So basically, the way I'm going to do it is with SQL injection. Some of you who are a bit more tech savvy might have heard of it, but if you haven't, it's to do with databases. If you don't know what a database is essentially a persistent, organised store of related data. So anything about addresses, people, passwords, hashed passwords hopefully, things that are related together, stored en masse, essentially. But yeah, so SQL injection, SQL, structured query language, is the language you use to manipulate databases for the most part. And SQL injection is putting SQL where it should not be. Usually for the purposes of getting something out of a database that you should not be getting out of a database. And this is usually done through unsanitized inputs on certain applications, such as a username password field box. As you can see, if you type in a certain SQL statement, which you can see in the capital letters at the top, you can spit out a bit of database that somebody shouldn't be seeing, generally. So if we I think from this point we'll get to the video.
Okay.
So due to Edarome being something,
Windows.
we can't do, what did you say, sorry?
Oh right, okay, is it
It's the
that one?
yeah, that's the one. You just pause it though for a start.
I think that's on pause. Oh,
Yeah.
okay.
We've got it? Yeah, cool.
Yep.
So due to Edarome being the way it is, I can't do a live demonstration because it involves VPNs, and they don't like that. And to be fair, it's probably for the best. So this is a recording taken from my laptop moments before it died, which is why I'm doing it on James's laptop. Basically displaying how I went about this. So yeah, I will commence the video and try and narrate it in a sensible way. Hopefully it's large enough that you can see what's going on. But yeah. So, hello. Yeah, this is my demonstration. I hope this is giving you a bit of nostalgia to the old unregistered Bandicam YouTube videos from 2011. But yeah. Oh, right, cool. Yeah. So yeah, we'll start off with this. So this is CMS made simple, content management system made simple. It's a bit of software that you can put on a server to help you manage your server contents and make decent websites. So if we're just enumerating this page, looking for a way in, you can have a look, and as you can see there, I've got a name, Mitch. It's probably a bit small on there, but these are things you want to look out for if you're just sort of looking into things. So Mitch is the guy who's running it. And if you're looking down there, we've got a version number, which I don't know if you can see because it's probably well small, but it's 2.2.8. So these are useful things you want to look out for if you're looking to do a bit of penetration testing. And your friend for this is Google. A bit of Google through goes a long way. Look up some exploits for that version. Let's see what goes on. Right, here we go. We've got an SQL injection, who'd have thought? And it works on versions less than 2.2.10. And as you can see attached is a download section where you can download the exploit that someone else has written. And there is a Python script. Some of you might have used Python before. It's just a nice language for quickly writing up things that can do things if you're not bothered about speed. But if you take a closer look at this, some of you might know that that's Python 2. So when I was downloading this, I quickly adapted it to Python 3, so it was a bit less yucky. But essentially, what this does is uses SQL injection on a timed basis to measure and brute force a password and dump it to the screen in the terminal. And we can do this on a, we can reasonably suggest that we're going to do this because we know that the password's weak, and I'll show you why in a minute. But yeah, here we go, what am I saying from the past? We have this file downloaded, we do, but I adapted it to Python 3. But yeah, Python 2 is usually, so we don't like that. So yeah, if you look here, I've made a little directory. I've renamed it to something a bit more sensible. So it's CMS MS SQLI, which is Content Management System Made Simple SQL Injection. And also million.txt, which is a file I pulled off the internet for free, which is a list of unhashed passwords, the top 1 million, most common. And you can use this to very good effect at brute forcing passwords. It's free to download. And we will use it to dictionary attack the password. So what we can use is those lists of passwords to guess what the password might be. And when you've got 1 million of them, it's quite hard to go wrong. But yeah, so if we cat out for Mitch, this is how we know that the password's weak, because this is taken from a capture the flag game. And as you can see, Mitch is getting a bit of a slating because he's made a bad password. Fair enough. We have a reason to believe that we can brute force this, essentially, given that. If you made a strong password, a lot less likely. So, are we going to run the exploit? Yeah, let's run the exploit. So this looks quite pretty when you put it in the terminal, but in terms of actually explaining what it does, I'll quickly go through, because this will take a few minutes to do, how it sort of works. I hope you can all sort of see the whiteboard, but the way that this sort of goes about it, yeah, there you go, that's very happy, isn't it? Right, so essentially we've got a database in the sky somewhere. Call it data, right? And then you've got little old us, call that M for machine. And let's say that the password for this account is called cheese, right? Something simple, something weak. We want to see if we can brute force it. So we're going to go through every letter in the alphabet and ASCII and symbols and things and see if we can figure it out. So we can try with A, just a lowercase a. Is that right? Database is going to look at that and say A is not C, so no, straight away. Get that? A is straight away, no. We can do that with B, straight away, no, it's not C, right? Let's try again, but this time let's try C. Okay, C's C, C's C and cheese, alright, that's right. Alright, H, no, wrong. But you see, that took a bit more time. So what we can do is carry on. We know that C is now correct in a certain capacity, right? So we can carry on. Let's go through the letters again. So we'll go through CA, CB, whatever. Go through again. What about CH? Oh yeah, C is right, H is right. That takes more time to evaluate whether or not that's right or wrong. We can use this, and that's what that program up there is doing right now, to try to figure it out. And it will essentially go through until eventually it goes through every possible string of characters, and it no longer increases the time to find it, at which point it finds the password, and it will find it in a minute. When it's found the email, as you can see, it's done the exact same thing with the username, niche, as we found before, but we could have half guessed that. And the email, admin@admin.com, how creative. But essentially, we're using a timing to discover different letters, like in Hangman, of the password in consecutive order. And that's how the timed SQLI works, and hopefully this won't take too much longer, but we'll soon find out why that password was so weak. But it wasn't, well, it wasn't password, but it was close. And it does look very good on the terminal, doesn't it? We're getting there. Come on. Hey, there we go. Password cracked. Secret. The cheese was secret, right? That was the password we managed to crack using the software that we adapted from online. Easy as that. So yeah, that was us breaking into the password on a admin page for a content management system online. Thank you. But yeah, so that's all well and good. But how do we get around that? Next slide. So how do we prevent that attack? Well, for a start, make strong passwords. See that table for a bit more information, but in essence, big password good, small password bad, more symbols good, and if you just look at the different, something like secret, how many letters is in secret? 6? 6 letters. What's that going to take? Numbers only, letters only, instant, straight away. Well, that was effectively instantly, and we brute forced it the hard way. But if you had a supercomputer on that, it wouldn't even be a problem. And then you look at the other end of the scale, 18 characters with everything involved. You're looking at the age of the universe plus, you know, just forever. You're never cracking that. And there's other ways you can get around it. So, for instance of that application, you shouldn't be having stuff be able to time inputs. The fact that we knew stuff because of time is bad. That shouldn't happen. So the way we can get around that is either uniformly return output, so that it always takes the same amount of time, that way our break-in doesn't work, or randomize it so that our break-in will just return gibberish. Next slide. So yeah, what we do as a society, essentially, I will be running workshops on stuff very similar to this on a sort of weekly basis if possible. I intend to do it sort of Friday evenings, but not too evening in the evening, so that you can have time to breathe. And I will be basically sharing stuff on the Discord about cybersecurity, trying to build a bit of a community in there, getting people involved with like CTFs and learning. If any of you do anything cool, I want to see it in there. You know, if you've gone on Hack the Box or Try Hack Me, done anything interesting, stick it in there, get a thumbs up and a Hacker Man react from everyone in the chat. So yeah, but in essence, we're here to have a laugh, learn a bit of stuff. Yeah, so next slide. Any questions, really? Yep.
Now, you say the download from previous versions. What exactly did they do to remedy that issue in your business?
Probably something like not having this be timed and also sanitising the input box on the page. So it would have been more likely, I would assume, that they would sanitise the input boxes. What did you say, sorry?
Probably using bad statements.
Yeah, so making sure that you can't put SQL in there in the first place, because that, in terms of getting SQL into a database like that, that is like code red. Like, that is full bad. So you don't want that happening for any reason. So it would have been something to that vein. I don't exactly know, but you can kind of tell that it was a serious issue because this was 2.2.8, and by 2.2.10 they'd already fixed it. So it must have been something very high up the list. Blue coat? SQL. Well, SQL was the way that we got in. What do you mean by fix the problem?
Guess MongoDB, but that has its own
Yeah,
issues and drawbacks. Your best bet is to just use like what's now considered the secure standard with database of prepared statements, where you basically say, I'm going to have some input here. It is input. Do not try to execute it. Be very careful with it.
Yeah.
So
SQL is like it's the way. To be honest, like you're not realistically gonna be able to get around using SQL on any scale, unfortunately. Well, for that case, but SQL is good, so it's not really a problem. Yeah. Yeah, so I think that one actually used MD5. When I was like combing through the source code, it was using MD5 hash, which is pretty standard.
No, it's not.
Is it not?
No, MD5's been broken for years.
Well, I apologise. Apparently not then. They should have used a better one. There you go. I've just seen it a lot recently. But,
It's generally because it's just easy to generate. And it's
well, there you
good
go.
enough for
Use a better
CPUs.
one is the long and short of it. Yeah. Cool. Thank you. Am I on time?
I think so. Right, Toby, you're up.
I'm going to be really awkward and set up my own laptop for this, because these slides were a mess. There we go.
Good. It's not. Does take a second. Okay. And hopefully, let me just change the text. Is it bit shifts?
Yes, that's fine. Mind you, it's on the slide anyway, so don't worry about it. You able to hear me from the back, everyone? Cool, I'll take those smiles as a yes. Cool, so hello everyone. This is my talk about coding for an art gallery, or how I learned that user testing is really important. So I'll say a little bit about me first. So my name's Toby. I've been involved on and off with Hacksoc since about 2016, and I used to be the hack secretary for Hacksoc. So my job was to organize Hacknots in 2018. So that was a bundle of fun to do. It's really awesome to be invited back to speak in front of everyone here at Hacksoc. Now I work for GoDaddy, and I work on APIs. You might be wondering why a guy that works on APIs is giving you a talk about design, but I'll ask you to not question that, please. So what's this talk about? So basically the gist of it is that it's one thing to go out and write a bunch of code. I think we've all been there where, well, a lot of us probably have been there where we tend to get lost in the process of building something. We have this idea in our heads, and we just want to go and make it, right? But you have to consider that real people are going to use the stuff that you make. So it's really important to think about how those users are going to interact with it. You know, it's no use splurging stuff onto the screen if it's no use to anyone, they don't know how to use it. So making sure the thing you make is both safe and easy to use for your target audience is super important. So a little bit of context about the art gallery thing. So in 2017, I helped a good friend of mine with their final project for their Masters of Arts, which was really awesome to do. He may or may not have heavily influenced the presentation. I was out here writing these slides at like 1 in the morning, he was in Discord, so bear with me here. So there's two main parts to the project. So there is the Enigma project, and there's Calum as well. Both of these were displayed in a gallery as part of the final presentation, so hence the talk title. I didn't clickbait you, don't worry. So I'll give you a little run through of Enigma. So Enigma is a puzzle game that we created It was designed to mimic the look and feel of like an old BBS system from like the 80s, 90s. So we had this big like CRT thing. It was all text-based. It was just using like, I can't forget how we did it. We didn't use cursors, we just did it all manually, which was bad, but we did lots of fancy line drawing on the screen, ASCII characters and stuff. It looks really cool as far as like, it really nailed the look of that old BBS that we were going for. The purpose of Enigma was to educate the public on issues such as encryption and privacy. So obviously it's been a big thing in the news for quite a few years now, where governments are looking to change the laws around privacy, encryption. So that was just to sort of raise awareness to the public that this is an issue. And there were lots of interesting like quotes in there from politicians and stuff that had said some interesting things about encryption. So that was kind of the gist of it. So there was also some posters in the background as well that you will saw at the start. A lot of these gave clues for the puzzles, and you can kind of see them there too. So this image on the right here is Enigma. So those posters in the background provided a lot of clues for the puzzles. There was like ciphers and stuff in there you had to solve to get the answers. And there was a Bitcoin prize for anybody who was able to solve all of the puzzles. We wrote it in C# on a Raspberry Pi using Mono, because that was the style at the time. It wasn't. But that was how that was what I knew. So that was basically, excuse me while I mute my phone. That was why I did that. The source code is available on GitHub, and I will have a link tree at the end, a little QR code that you can scan on your phone, if that's okay. You can go and look at the source code, but be warned, it's pretty awful. But hey, it worked, and we got a lot of positive feedback out of it, and the project went really well. So, and then the next thing I worked on as part of the same sort of encompassing project was Calum. So Calum is a series of 360-degree tours. So the artist went to a bunch of cathedrals and did these really interesting like 360-degree tours. You could click around them and navigate to different parts. The idea behind this was that people who had physical disabilities, who otherwise could not go and experience those places themselves, because cathedrals are not the most accessible places, could experience them. So the idea was we had these spheres, these physical spheres you could place on a reader, and that would go ahead and open up a tour using an application called RoundMe, which is how you display the tours. So you can do it in the web. We also had VR as well, so we had like Google Cardboard headsets. We could hand them out and people could look inside and do the tours that way. It was a really cool little project. I wrote the front end for that in Java. I'm going to try not to go too much into the implementation of things here because it's not like entirely relevant to the talk itself, but I got to learn a lot about it. So basically these spheres had NFC tags in them, so I got to learn a lot about how those work and like smart card readers and stuff. Again, there'll be links at the end where you can also go and explore the source code, which is also awful. And you can also go and look on the artist's portfolio. If you're more interested in the projects and stuff, you can actually go around on his website and click around all these tours. They're super cool. I really recommend you give them a look. So, why this talk? So, while we were developing this, these projects, we had to shatter a lot of our assumptions that we made about how people interacted with our software, right? Because as a programmer, it's very easy to make assumptions about, oh yeah, well I wrote it this way, so this is how the user's going to do it, etc., etc. So I guess I'm here to teach you to kind of get rid of those assumptions, right? It's important to also highlight the importance of getting users to actually test your stuff. You'll get the best feedback out of your actual users, and I'll touch on that a little bit later. And I've kind of broken it down into a few sort of key lessons that we learned. So lesson number 1 is to always assume the worst in your user. Alex is going to be super happy that I'm mentioning this, but you always have to assume that your user is going to try and break whatever it is you've made. I'm sure we've all been there. You know, if any of you have made something for a hackathon or, you know, just posted something on the internet, someone's always going to try their luck with it. Like, there are entire classes of attacks that involve, like, people messing with user input. For example, there's SQL injection, which was mentioned before. There's, like, cross-site scripting attacks and things like that. So you have to be really careful to make sure that your user can't break whatever it is that you've put out there. Therefore, it's super important to get someone to test it before you put it out there. I know it's hard as students, but within Hacksoc, I suppose, we're all very open to trying things out. So plonk your product in front of people and get them to say, break this. And you trust me, you'll find like things you never even considered. So I'll go over an example of this. So how did we learn that lesson ourselves? So while we were working on Kalem, basically the way it worked was we had this Java application would take over the whole screen, and it would give the user instructions like place the globe onto the reader. And we discovered it was really easy for users to break out of Chrome's kiosk mode. So if you don't know what kiosk mode is, it's a special mode of a web browser that will basically disable all of the menu bars. So you can't click close, or you can't open tabs, or you can't navigate to a new URL, for example. So users could do a lot of things to break out, because Chrome's kiosk mode back then was not the best. There was a lot of ways that users could close the Chrome window, and we wanted to try and avoid that. So we went off and did all sorts of hacky things to try and stop the users from doing this. Like we would detect if Chrome had been killed and then reopen it and keep it in the foreground and stuff like this. We way overcomplicated our solution to this, and then we had a little realization. So I'm actually going to, so users could they could also do Alt-Tab, Alt-F4. They could right-click to bring up dialog boxes and stuff. So I'm going to leave it to the audience.
That's the pizza.
Hey. I'm going to leave it to the audience. If you want, any of you want to raise your hands and try and figure out how we solved that problem. Yes, towards the front in the cardigan. Pardon? Wow, you guys got that quickly. So I wasn't actually expecting that, but yeah, fair enough. The user can't use keyboard shortcuts to break out of the kiosk mode if they didn't have a keyboard. I also didn't mention that we ran everything on an iMac, so they only had a one-button mouse, so they couldn't right-click or anything. And this also leads me really nicely onto the next lesson. Keep it simple. It's so easy to fall into that rabbit hole of just over-engineering solutions to everything. Like when we discovered that Chrome kiosk issue was a thing, my immediate instinctive response was to go off and write a bunch of code, fix this. This has to not be an issue. So in terms of the way you design your product, you want to kind of reduce the number of steps that it takes to perform your most important tasks. So in the case of Kalem, for example, we shrunk things so we didn't want people like grabbing the mouse and having to click onto a link to open up the round me. We just wanted these nice big physical globes that you could place onto your onto the reader, right? So again, it's also important that you place that product in front of someone who is a member of that target audience, right? If you think you found a problem, get someone to test it. You never know. It might not be an issue. They might not even discover it. But it's important to get that feedback before you then go run off and try and fix it, because you never know. It might just be no problem. So yeah, as I've already touched upon before, we kind of restricted ourselves to this one input method, one interaction to launch the tools. And doing so, because we were aiming for people who might have physical accessibility needs, we tried to keep things that simple. And we got a lot of positive feedback when we put this in front of people to test and play with. So that was really awesome. And I'm just going to move on to my final lesson here and mention that feedback is king. You really do need to, I really do need to emphasize how important it is that you keep putting, as you iterate on your product, you need to keep putting it in front of people, right? And make sure that they can intuit how to use it. Because there's no use in creating something that only you know how to use. It could be so complicated to someone else, but to you, because you made it, you know how it works. But again, kind of useless to Joe Public. So the best way I find to do this is hand them your product and say, right, I want you to use this to do this, and watch how they do it. Take notes, listen to everything they say, and just kind of go from there, because you will get the best feedback from the people who are actually going to use your product. Again, it's sort of it's good to make sure the people you're giving it to test actually sort of tally up with the target audience that you're aiming for, and sort of take plenty of notes, listen to everything, go fix it, iterate, keep going, keep doing this. Obviously, it's kind of hard as students because we don't have like these in the industry. You would have like a focus group that you would test with, right? But as students, hand it to your friend. Get them to play with it. See how it goes. Any bit of feedback that you get is super useful. So I kind of blasted through my talk. Not a problem because pizza's arrived, but yeah, it's tough for me to slow myself down. So you can go ahead if you want now and scan that big QR code, and that will take you to a page where you can go ahead and look at the source code. You can look at the artist portfolio. As a matter of fact, about 2 hours before I was due to deliver this talk, I got a call from the artist saying, hey, I'm on my way to Nottingham. So he's actually sitting in the audience right now. If you want to raise your hand, you can feel free. He's over there. So feel free to approach us as well. But I'm also, thanks for listening. I'm happy to take questions now. I'm also in the Discord as well. So if you want to chat with me there, you can also approach us in person. No problem. Any questions, anybody? Yes? So we did have one issue where someone was able to switch out of, so in Linux you can do Control-Alt and use the F keys to switch pseudo terminals, which are basically, in Linux you have lots of different terminals that you can switch between. So we disabled all but the default one to stop people from doing that. But other than that, we didn't really have any issues with that because we wrote code to catch like Control-C, so you couldn't Control-C your way out of it. Because I don't know if you don't know, Control-C in Linux sends a signal to your program to close. So we had to make sure we were catching that and not actually closing. Okay. Thanks for listening, everyone. Appreciate it. I'll leave the thing up for a sec. You can feel free to mess with it.
So, I'm not sure what the status of the pizza is, but tell you what, I'll go and find out because they all just left, and so I don't know how long it'll be. But yeah, I'll be back in a second, and I will tell you what's happening. Okay, so the pizza hasn't arrived yet, but it will be here any minute. So currently it's just the vegan ones that have arrived, which I'm not sure why, but yeah, they'll be here any moment. I'll keep you updated.
Should I do my GFA talk then? Yeah. Can I unplug Toby's laptop? Special fourth talk. Let's talk. Is that share properly?
I can have my laptop, please.
You are mirrored. Okay, lovely. Alright. While we wait for the pizzas to arrive, we've got a couple, we've got 50 more on the way, so keep regaining my breath. I'm going to explain to you the magic of JPEG compression. How we get small images suitable for the web, suitable for making the rich, image-rich world that we know of these days. So JPEG, what is it? It's a portable image compression format developed in 1992. So JPEG is actually a committee of people who came together in the late 80s to design this image format. What we know as JPEG today is actually a subset of the JPEG standard that the JPEG committee made, which is known as the JPEG file interchange format. This is because after a lot of work, the JPEG committee made this fantastic standard with support for all kinds of images. Unfortunately, it was really complex and they didn't provide a reference implementation, so it was never properly implemented fully. And what actually got implemented was a small subset which became the JPEG file interchange format. So major benefits was it was patent free, so it meant it could be freely used and used widely across different computer systems. It was good compression, so you could compress your photo and it would be smaller than the uncompressed photo, even if you included the decoder program with the photo. Because back in the late 80s and early 90s, what you had before JPEG was you could either share an uncompressed image, which was massive, or you could use a compressed format, but they were all proprietary and only worked on specific computer systems. So if your friend had the same kind of computer system as you, it was all right, they could see your images. Otherwise, you're out of luck. And you had to use these giant uncompressed image formats that wouldn't even fit on your 3¼ inch floppy disk. Fortunately, JPEG came and saved the day. So, what is an image? An image is an array of pixels. And each pixel is really just a brightness value from 0 to an arbitrary value, in most cases with 8-bit 255. To get color, which is quite popular in images, we actually have three what are known as channels, each with that brightness. So you've got a blue one, you've got a green one, and a red one in RGB images, which is quite common because it's what cameras produce and it's what displays take in to show. However, that's not quite how humans see color. So humans, in the back of their eye, have things called rods and cones. And rods are great at sensing light. And they're really good at that. They can tell small differences between the quantity of light hitting them, and that's what allows you to see texture and things like that. And then we've got cones, which allows us to see colour. But the cones, there are not very many of them. So it actually means humans are pretty terrible at seeing colour. In particular, we have sort of three different types. One that does red, one that does blue, and one that does green. They actually do sort of a range of wavelengths, but they predominantly are red, green, and blue. And you've actually got about twice as many green ones as you do of the blue and red. So that's why humans are a lot better at seeing green than other colours at the same emission levels. This becomes particularly relevant when we use clever colour encoding like YCBCR. So this is where instead of encoding your image data as basically an image of R, so image of red, image of green, and then image of blue, you actually try and model it a bit closer to how the human eye sees colour. So you have your Y channel, which is brightness, and that's what the human eye is really good at seeing. Then you have CB, which is relative blueness. So this goes from yellow to blue and doesn't contain any kind of brightness information, so it's all a flat image. And then you've also got relative redness, which goes from green to red, I think. And these are good because they quite closely model how perceptive the human eye is. And it means we can do clever tricks, like chroma subsampling. So, because the human eye is not very good at seeing colour, we can cheat with our images and only store half as many pixels with colour, for example. So this is a good example. So on the top three images are red, green, and blue. So this is where I've chroma subsampled just one channel. So top left one, I've chroma subsampled the red. Top middle, chroma subsampled the green. That one, the blue. On the bottom, I've done the same, but with YCBR, and I've chroma subsampled each channel. So what you can see is that if you just look at the top row, you can really notice how the human eye notices green a lot more than the other colours. Because I've removed the exact same amount of data from each image, but the green one looks significantly worse than the red or the blue. It's even worse if you actually look at the luminance one in the bottom corner. That looks really pixely. But if you're looking closely, you can see all the colour information's there with full resolution. If you look at the lips, for example, you can see that the red is not pixelated at all. But because it doesn't have that brightness there, you can't see the definition, the contrast with the background to pick out the features. Whereas with the blue chromatins and red chromatins channel, I've removed the same amount of data, but you basically can't tell. It looks like a normal photo. So that's how we can get rid of quite a lot of data. But this is the next step. And this is where JPEG gets really clever. So rather than storing our data as pixels, each with a brightness value, what we can do is we can take 8x8 chunks of pixels, so 8 pixels by 8 pixels, so 64 pixels in total, and we can, instead of storing each one of them, we can work out a pattern that represents that 8x8 pixel grid. And there's a whole bunch of patterns, so this grid here, that if you add up, say, a little bit of that one, 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 you can replicate any pattern possible within that 64 pixels. So this is to get to this is a process known as discrete cosine transformation, which is some very clever maths that I haven't quite figured out myself. But basically, it means that instead of having pixel brightness values, you can get coefficients for how much of each of these patterns is in your 8x8 pixel block. So that's actually made our image slightly bigger in terms of file size. But then comes the next step, quantization. So this is where we can consider that the human eye, although it's very good at seeing a lot of things, is not very good at seeing detail. So we can actually get rid of the high frequency data in this bottom corner, because we don't see it very well. We see much more the low frequencies, the big colours, big brightness blocks in the top left corner. So if we reduce with this quantization table, so we divide all the numbers through by the values of this quantization table, and then round them to the nearest integer. And because we can put big values in the bottom corner, because the human eye doesn't see that much, it means we can turn a lot of those values to 0. And this hasn't saved us any bytes yet, but it means we can do some very clever things with encoding. So, what we can do is we can read our pattern, our coefficients, in a zigzag pattern. So we go along from the top corner, go up, down, and then at some point, say when we get to that 1 there, all the rest are 0. And so instead of saving them, we know there's got to be 64 numbers there, so we just don't bother to write them in. There you go, saved a whole bunch of bytes there. So yeah, if we don't store runs of zeros, that saves us a whole bunch of bytes. Then we can also use something called delta encoding, whereas instead of storing the value 90, -4, -1, 6, etc., we just store the difference from the previous value. This has the effect of giving us values that are quite similar. So we get a lot of repeat values because we all quantize them to integers. And so we'll get a lot of +1s, a lot of -1s, a lot of +2s, a lot of -2, a lot of zeros. And that is really helpful for our next step, Huffman encoding, which is a lossless compression technique invented in 1974 by a mathematician called David Huffman. I want to write a PhD paper like him that's only 12 pages. So this is a way of representing data that can make it very quick to, or very small to store. So what you do is you line up all your data in terms of how frequently it occurs. So if you've got loads of zeros, and then a few less ones, few less minus ones, few less minus two, few less twos, you keep doing that till you've lined up all the differences that you worked out in the previous step. Then you take the two least common ones and you put them together into a tree and join them up. Then you put that back into your list in wherever it should go. You keep doing that from the bottom of the list, joining them up, putting them back into the list until you've joined up everything into one giant tree like this. And then what you can do is to get to a specific value, you can denote one branch on the tree is 1 and 1 is 0. And then so using 2 bits you can go 1 1 to get to A or 1 0 to get to B. And that doesn't save any data if they're evenly distributed like this. But the whole point of all the steps we've done previously is to make it not evenly distributed. So we end up with lots of very common values. And so we can end up getting to them within much fewer steps. So we might only have to go 1 or 2 branches down, whereas to get to the least common ones, we might have to go 5 or 6 branches down. And because of that, we save a whole lot of bits in storing our data. And that's basically how JPEG works. We throw away the pixels we can't see anyway, because who needs them? We quantize away the high frequency detail, because we can't see them. And we squish it all down with clever mathematics to make it take up the least amount of space that it possibly can. And it's served us very well over the past 30 years. It's certainly been a dominant format. You won't go on Facebook or Twitter or any other common site without encountering a JPEG. And generally, it works great. There are some cases it doesn't work. So things like text or sharp graphics with lots of lines, that suffers from not obeying our assumptions. So text, these high frequency bits, are actually quite important. If you get rid of them, you end up with that nice JPEG artifact and you get on your crispy memes. Same with chroma subsampling. If you've got a line of direct, like a specific color, you get weird fringing if it's smooth, but the color goes on further than the most of the brightness does. But for the most part, especially for photographic content, JPEG serves us very well. In the future, in fact even in the present, there are standards trying to displace JPEG. So WebP tried in the past and achieved limited success. But really you don't see WebP out of automatic image optimization for websites. Another encoding format trying to follow up after WebP is the AVIF format. So that's based off the AV1 video codec developed by Facebook, Google, literally everyone involved in video. And that can achieve quite good compression ratios, but it does suffer from being video codec derived. So it's got quite a limited maximum resolution, so only 16K by 16K, and it's got several other drawbacks. I just said the most likely contender to displace JPEG is a new format called JPEG XL, also developed by the International Standards Organization. So it's, in theory, the same committee that developed the original JPEG. In practice, it's all completely different people, but it's the same organization. So that has a bunch of clever things. It's actually a dedicated image format, so it's got things to handle photographic modes. It's got a dedicated lossless mode for handling graphics and text. And it's also got a very clever recompression mode for JPEG, where it can take existing JPEG files and make them smaller without losing any quality. So I think that's probably going to be the future, but even if we don't go into the future, JPEG is still very good. It gets our giant bitmaps down to manageable sizes that we can serve on mobile phones. And yeah, images are great. Thank you for listening to my talk. there's my sources if you want to check them out. Any questions? All right.
Did we get pizza? The pizza's not here yet.
So, yeah.
There are 2 pizzas that have arrived.
Do you know when it's going to arrive? Do you know when it's going to arrive?
They were meant to arrive
It
quarter of an hour ago.
Yeah,
yeah, not sure what's happening.
We haven't even got a call from them or anything. I don't think.
We definitely ordered it for today, right?
Yeah.
You're 100% certain? Okay.
I
Right.
mean, the guy who was talking about another delivery, I think, wasn't he? Or
I
was
was it?
when we went to.
Well, I don't know really what to say.
We could call Domino's.
We could call them.
Okay. I'm
I-
going to step out for pizza.
All right.
Right. I'm supposed to have. He's just out there. This seems like a good time to demonstrate the actual
Oh
game
yeah,
on the
do that.
oscilloscope.
That will waste some time. Okay.
So
I'm going to go and see what's going on, but I'll be back in a minute.
okay. So we won't actually be streaming the demo of the oscilloscope game to YouTube because apparently they're getting like 1 frame per second on the actual video, quite literally. I need to actually plug this in. So I'll do this. I'm actually not sure how well you'll be able to see this because it's a pretty small screen, but it might be okay. Sorry?
Feel free to
That's true. Yeah. You can just come down if you want to get a closer look. I'm just going to have it running and hopefully it works. There we go. It's on. Yeah, cool. All good. So, I mean, here it is. I mean, people at the back, can you see this like at all? You can see it, can you? Okay. I mean, it's real. I would be surprised if you could see it clearly, but anyway, it's just the game Asteroids. Luckily, it's a game that you probably all know what it looks like, so the actual specifics of it. But here we go. It's Asteroids running on a machine that isn't at all designed to run games.
Is there a leaderboard?
There's no leaderboard, no.
God damn it.
It's a pretty limited implementation, unfortunately. There's no leaderboard. There's no score. But yeah, I did die. You have 3 lives. If you lose them all, then you die. Nothing. If you actually manage to destroy all the asteroids, nothing happens. I forgot to implement that. In the game we made using C on the actual computer, there's like a game over screen and stuff. That one's a way more fully featured one. I pretty much just used the same code from that and then just ported it to the oscilloscope, but missing out a few features because the Arduino IDE is kind of annoying and it's really difficult to use multiple files. So I did it all in one file, which I didn't really enjoy. Hopefully the pizza will be here soon, but if not, I mean, you can just walk around and I guess do stuff. I mean, people can, you can come down and have a go on the game if you want, but I can't promise that it will be that entertaining. But it probably was back in the late 70s.
Anyone ever tried that?
So people definitely have played games on this oscilloscope, and in fact there was actually this game sponsor who was which, it was basically just a game console you could play games, but instead of the normal screen it used this kind of event screen. We may well be.
How much complexity can you go?
So, yeah,
I tried a few things. Because it's not the oscilloscope processing, so it just needs to be able to use the digital draw things faster. Well, in a way, like, you only have to draw the amount of lines that are there. So if you have less stuff, you can draw it quicker.
Did you want to have a go?
I tried a few things, but I wrote a little Python.
Right, so moving, I don't know if you know the controls for Astro, but essentially it has like a thruster, and then you can rotate, but you can't like straight shot. So that's for rotating clockwise and anti-clockwise. Shoot.
Hello, everybody.
Forwards, that is the like. There's a button on the keyboard.
Just need your time for 2 seconds. Turns out that Domino's are absolutely lovely and punctual and everything when it comes to pizza. So supposedly the driver's on their way. That's all I can tell you with respect to pizza. Very sorry.
Don't worry, he's on his way to make it here for 7:30.
Yeah. We do. Do we have any sort of vegans, lactose-free, anything like that? We have 2 vegan pizzas. If there are 3 vegans, you may have to fight to the death for them. So they're outside if you want to grab them now.
Because they got here early, we don't want them to get cold or anything.
Yeah, they arrived about 15 minutes.
If I show you,
Yes, they're in the main room.
It's not very ergo, but like.
Is the stream still going?
Well,
Oh, are we on the? Oh yeah,
apparently
right.
so.
Okay. Wait, we should put
Me and
the
Jacob were on this project.
what's it called on. You know that thingy. What's that have to do
Oh
with
yeah,
it?
that's on.
Oh, is that
Yeah.
is that what?
That's
okay,
what's
right.
on. This is a preview site,
okay.
so you can preview what you're doing, and then you can transition it. So. I put it in studio mode now.
Rotate clockwise
Check
and
it out.
clockwise, you move forwards, shoot, and don't worry about the start.
Good.
So press shoot start. You press that button.
I am running it if I remember correctly, so what I'm doing is after each sort of frame is drawn, it just waits in the code until the next one.
It's a good game, actually.
I love just how it looks. It was really good.
Alright, Alex, I won it. Easy.
Have you won it? Oh, Jacob. Yeah. I was more involved with the testing side of it, so I've never actually seen this in the play. I read the software. If you come off one side, it works around.